Good morning, friends. Today I want to teach terms regarding photoelectric effect. Terms regarding photoelectric effect. Photoelectric effect.
That's right in center.
Okay. What are the terms regarding photoelectric effect? One is work function. Work function, that is W, R5, which is denoted as. Another one is threshold frequency. Threshold frequency. This is nu naught. Another one is threshold wavelength. Threshold wavelength. This is lambda naught. The last one is stopping potential. So these terms are useful while we are calculating the problems. Stopping potential V naught or Vs. So what is work function? Work function WR5. Work function means the minimum amount of energy. The minimum amount of energy. The minimum amount of energy. Amount of energy required to remove an electron from the metal surface. From the metal surface. That is work function. Work function W is equals to h nu naught. Where nu naught is threshold frequency, this is the Planck's constant. Okay. As we know that C is equals to nu lambda. Nu is equals to C by lambda. So W is equals to C by lambda. Right? And nu naught is equals to C by lambda naught. So W is equals to C by lambda naught. This is the work function. Work function W is equal to h nu naught depends on, and it is denoted as, it measured in electron volt. W is in electron volt. What is electron volt? 1 electron volt. The energy gained by an electron, the energy gained by an electron, to accelerate 1 volt of potential difference. 1 volt of potential difference. 1 volt of potential difference. So 1 eV is equals to 1 into electron charge 1.62 10 to the power of minus 19 coulomb. 1 volt, 1 joule by coulomb. Coulomb cancel. 1.62 10 to the power of minus 19 joule. So 1 electron volt is how much? 1 electron volt is equals to 1.62 10 to the power of minus 1. Okay. Work function depends on nature of the metal surface or nature of the photo emitter. Nature of the metal surface or nature of the photo emitter, right? So work function is different for different values. W is for different metals. So why we are using these two, sir? Why we are highest work function is for platinum. That is 5.65 electron volt. Lowest work function is for cesium. That is 2.14 electron volt. So the best metal used for photoelectric effect is cesium. because of its lowest work function. Because of its lowest work function. Lowest work function. Understand? This is about the work function. The problem regarding work function W is equal to h naught, SC by lambda and SC by lambda naught. So electron volt value. Okay, now the terms regarding photoelectric effect, one of the term is work function. Now we are going to discuss about threshold frequency. Threshold frequency. Threshold. The word threshold frequency. Threshold means starting. The minimum frequency. The minimum frequency at which photoelectric emission takes place. Photoelectric emission takes place. Is called threshold frequency. Here very important point, threshold frequency U naught is equals to W by H. We can calculate threshold frequency by using work function and Planck's constant. Okay, now threshold frequency U naught, incident frequency nu. So which one is more? Incident frequency is more because of, if you are giving more frequency then only they have chance to give the less frequency. So nu greater than U naught. Threshold frequency is nu greater than U naught. H nu minus H nu naught. Threshold frequency also depends on nature of metal surface. Nature of metal surface. Right? Now we are going to discuss about threshold wavelength. Threshold wavelength. Lambda naught. Threshold means starting. Here the minimum frequency or the maximum wavelength. The maximum wavelength at which photoelectric emission takes place. Right? That is threshold wavelength. Threshold wavelength can be calculated by using W is equal to C by lambda naught. Because of W is equal to h naught, U naught is C by lambda naught. Right? Lambda naught is equal to C by W, which is threshold wavelength. So your incident wavelength and threshold wavelength, which is greater? Threshold wavelength is greater than incident wavelength. Lambda naught is greater than lambda. This threshold wavelength also depends on nature of the metal surface or photo emitter, independent of intensity and frequency. So less amount of frequency also we have chance to get threshold wavelength. Low amount of frequency of light also threshold wavelength. Right. So W is equal to C by lambda naught. H value 6.625 into 10 to the power of minus 34 joule second. C value speed of light 3 into 10 to the power of 8 meter per second by lambda naught. Then here 6.6 into 3, 6 are 18 and 3 6 are 9, 18 plus 1, 19.8 into 10 to the power of minus 26 by what? Lambda. Here it is joules meter per second. We can write electron volt, that is 19.8 into 10 to the power of minus 26. This is 1.6 into 10 to the power of minus 19. Up to till now this is joule, it is in electron volt. This is 12.4 into 10 to the power of minus 7 electron volt by lambda naught. Right? This is 12,400 into 10 to the power of minus 10. The lambda naught is in electron volt. Lambda naught is in angstrom. This is electron volt. So we can write W is equals to 12,400 by lambda naught. Lambda naught should be in angstrom. W is in electron volt. W is in electron volt. Very very important formula for the application while we are calculating the problems. Shortcut. We are giving lambda naught. We have to calculate W like that. So need not to write all things H and C. Understand? So threshold wavelength lambda naught is equals to 12,400 by W. Here lambda naught is in angstrom, W is in electron volt. Right? This is threshold wavelength. Now stopping potential. Stopping potential. Stopping potential is V naught. Stopping potential, stopping means stop. At which negative potential, the photoelectric current becomes zero. Photoelectric current becomes zero. Photoelectric current becomes zero means photoelectric emission does not take place. That is stopping potential. Stopping potential Ke is equals to EV naught. V naught is equals to Ke by E. Kinetic energy by electron. Stopping potential is in volt. Kinetic energy is in electron volt. Right? These are the terms regarding photoelectric effect. What are that? Work function, threshold frequency, threshold wavelength, and stopping potential. These four are very very essential for application of Einstein's photoelectric equation. Understand? Now I want to teach Einstein's photoelectric equation. Einstein's photoelectric equation. Einstein's photoelectric equation and applications. So almost a lot of applications will be there. That is very very important for the problems of JEE mains and advanced and for NEET students. So Einstein's photoelectric equation. According to Einstein, the total energy of incident photon, E is useful into two ways. One is for potential energy, P. Another one is for kinetic energy, K. Potential energy is nothing but work function. Already we know that what is work function, the minimum amount of energy required to remove an electron from the metal surface. So the total energy, some amount of energy useful to remove the electron from the work function. Some amount of energy useful to eject the electron with a speed. So E is equals to energy of incident photon. E is equals to h nu, that is hc by lambda. Ke is equals to kinetic energy of the emitted electron. Kinetic energy half mv square while moving with the speed, and ev naught. And potential energy nothing but work function. This is W is equals to h naught, that is hc by lambda naught. These three formulas are very very important. So according to Einstein's photoelectric equation, total energy of incident photon E is equals to Ke plus Va. E is equals to Ke plus W. So then Ke is equals to, this is equation 1. From that we have so many applications. Ke is equals to E minus W. Equation 1. Kinetic energy K is equals to E minus W. So applications of PE. First one, Ke is equals to E minus W. As we know that kinetic energy of emitted electron is half mv square. Half mv square is equals to E minus W. V square is equals to 2 into E minus W by M. V is equals to root over 2 into E minus W by M. This is the speed of the emitted electron. Speed of the emitted electron. This is already for J and main important. J and H. Definitely. For chemistry also we have the same formula. This is equation number 2. So V is equals to 2 into Hc by lambda minus W by M, right? So V is equals to 2 into Hc minus W lambda by M lambda. Already we got this question also for J, previous J, right? Equation number 3. Next V is equals to 2 into H nu minus W by M. H nu minus W by M. These are the different equations of speed of the emitted electron while we are calculating by using Einstein's photoelectric equation. Very, very important. Now, Ke is equals to E minus W, right? Ke is equals to EV naught is equals to E minus W, right? We have to calculate V naught, E minus W by E, right? So this is joule, this is joule, this is coulomb, this is electron volt, this is electron volt, this is electron. You can get by volt. Understand? Next, K is equals to E minus W, right? EV naught is equals to H nu minus H nu naught. V naught is equals to H nu minus nu naught by E. So V naught is equals to H by E into nu minus V naught. Very, very important. So V naught is equals to H by E into nu plus minus H by E into nu naught. So this is Y is equals to mx plus c, where m is H by E, slope intercept form. So let us plot a graph between threshold frequency and stopping potential. Stopping potential on which axis? Y axis. And here this is stopping potential, this is threshold frequency. This is equation number 6. By calculating stopping potential and threshold frequency by using a different manner. Understand? So EV naught is equals to H into nu minus nu naught, right? From that we can calculate threshold frequency and incident frequency. Threshold frequency and incident frequency, right? EV naught by H is equals to nu minus nu naught. EV naught by H is equals plus nu naught is equals to nu. This is the formula for incident frequency. Incident frequency. If they are given stopping potential, in similar way, nu naught is equals to nu minus EV naught by H. This is for stopping, this is for threshold frequency. So threshold frequency. Understand? This is the 7 and 8. Ke is equals to E minus W. E is equals to EV naught. Hc by lambda minus Hc by lambda naught. EV naught is equals to Hc into 1 by lambda minus 1 by lambda naught. So V naught is equals to Hc by E into 1 by lambda minus 1 by lambda naught. This is for if they are given incident level, the threshold level, if they are asking stopping potential. This is also previous JEE main and NEET concept. Very very important. So if lambda naught into Hc by E, lambda naught minus lambda by lambda naught, right? In a similar manner, Ke is equals to E minus W. Half mv square is equals to Hc by lambda minus Hc by lambda naught. Understand? V square is equals to 2Hc by m into 1 by lambda minus 1 by lambda naught. Understand? V is equals to root over 2Hc by m into 1 by lambda minus 1 by lambda naught. This is also a very very important useful problem for JEE mains and NEET. So these are the different types of applications of photoelectric equations. Next application, K is equals to E minus W, right? K is equals to half mv square H nu minus H nu naught. V square is equals to 2H by m into nu minus nu naught. V square is equals to 2H by m into nu minus nu naught. Next, for different kinetic energies Ke1 and Ke2, for different incident frequencies. So Ke is equals to E minus W. Okay. So Ke1 is equals to E1 minus W. For different kinetic energies Ke1, Ke2 for different incident frequencies on same metal surface. So W is same. So Ke2 is equals to E2 minus W. So Ke1 by Ke2 is equals to E1 by W minus E2 by W. This is the ratio of kinetic energies. Ratio of kinetic energies. But Ke is equals to half mv square. Half mv1 square is equals to half mv2 square. Is equals to E1 minus W by E2 minus W. V1 square by V2 square is equals to E1 minus W by E2 minus W. V1 by V2 is equals to root over E1 minus W by E2 minus W. This is very very important for JEE. The ratio of speeds, ratio of speeds for different energies and different same work function. Okay. Ke1 by Ke2 is equals to E1 minus W by E2 minus W. So Ke1 by Ke2 is equals to H nu1 minus H nu naught by H nu2 minus H nu naught. So Ke1 by Ke2 is equals to nu1 minus nu naught by nu2 minus nu naught. This is the ratio of kinetic energies. Ratio of kinetic energies in terms of incident frequency and threshold wavelength. This is the equation number 13 and 14. If ratio of kinetic energies Ke1 is to Ke2 is 1 is to K, ratio of kinetic energies Ke1 is to Ke2 is 1 is to K, then what happened? 1 by K is equals to nu1 minus nu0 by nu2 minus nu0. Nu2 minus nu0 is equals to K nu1 minus K nu0. So K nu1 minus nu2 is equals to K nu0 minus nu0. K minus 1 into nu0 is equals to K nu1 minus nu2. So nu0 is equals to K nu1 minus nu2 by K minus 1. This is for threshold frequency. This is also a previous year question. Understand? Similarly, if K1 by K2 is equals to K by 1, so K by 1 is equals to nu1 minus nu0 by nu2 minus nu0. K nu2 minus K nu0 is equals to nu1 minus nu0. K nu2 minus nu1 is equals to K nu0 minus nu0. So K nu2 minus nu1 is equals to K minus 1 into nu0. So nu0 is equals to K nu2 minus nu1 by K minus 1. This is also threshold frequency for different models. Understand? If K1 is E1, K2 is E2, then E1 by E2 is equals to nu1 minus nu0 by nu2 minus nu0. E1 nu2 minus E1 nu0 is equals to E2 nu1 minus E2 nu0. So E1 nu2 minus E2 nu1 is equals to E1 nu0 minus E2 nu0. So E1 nu2 minus E2 nu1 is equals to nu0 into E1 minus E2. So nu0 is equals to E1 nu2 minus E2 nu1 by E1 minus E2. If E1 is greater than E2, similarly nu0 is equals to E1 E2 nu1 minus E1 nu2 by E2 minus E1. If E2 greater than E1, this is the next application. These are the different applications for photoelectric effect and very important for the JEE and mains NEET aspirants. In depth of photoelectric effect and their applications. If E is equals to Ke plus W, Ke plus W, E1 is equals to K1 plus W for different kinetic energies and energies of digital photons. Ke2 is equals to K2 plus W. So this is A, this is B. E1 by E2 is equals to K1 plus W by K2 plus W. Hc by lambda 1 by Hc by lambda 2 is equals to K1 plus W by K2 plus W. Lambda 2 by lambda 1 is equals to K1 plus W by K2 plus W. K2 lambda 2 plus W lambda 2 is equals to K1 lambda 1 plus W lambda 1. K2 lambda 2 minus K1 lambda 1 is equals to W lambda 1 minus W lambda 2. So K2 lambda 2 minus K1 lambda 1 is equals to W into lambda 1 minus lambda. So W is equals to K2 lambda 2 minus K1 lambda 1 by lambda 1 minus lambda. Very very important for the work function. Work function. If different kinetic energies and incident wavelengths, lambda 1 greater than lambda 2. So W is equals to K2 lambda 2 minus K1 lambda 1 minus K2 lambda 2 by lambda 2 minus lambda 1. Lambda 2 is greater than lambda 1. This is the applications of Einstein's photoelectric effect.